Can you see? So it's going to be AB, that is one side, plus OC, that is another side, times height. Your height is your velocity. It can be this, it can be this. So let's take AE. AE. Once you know this value, you calculate it out. That will be the total distance traveled. Now that you understand this, you can go into some calculations. Let's consider some calculations to buttress our points. Let's consider the following questions under motion. All these questions we are going to look at now are typical past questions. And I want you to see how the question is being asked and the way we are going to answer it. Question number 1. A car has an initial velocity of 40 meters per second. Let's take it the parameters. Initial velocity of 40 meters per second and retard at 3 meters per second square. Retard, that is acceleration, which is 3 meters per second square. But they use the word retard, which means it's a negative of acceleration. Put velocity here. Calculate its velocity. What velocity is that? Final velocity. After 10 seconds. After 10 seconds. Recall. Acceleration is v minus u over t. As I have told you the other time. This is minus 3 is equal to, this is what we are looking for. This is 40 over what? Over 10 over 1. This is minus 30. V minus 4. Take v minus 4 to be equal to, okay, v minus 4 to be equal to minus 30. Okay, so that v is equal to minus 30 plus 40, which is equal to, what are we having here? If you remove minus 30 from 40, we have 10 meters per seconds. That's the answer. Simple calculation. I put minus here because we are told it's a retardation. It retards. Okay? So minus 3 over 1, v minus 4 over 10, cross multiply, minus 30. This is this. The whole of this, put it here. Then v is equal to minus 30 plus 40. If we remove minus 30 from plus 40, we have 10 meters per second. That's that. Question number 1. Let's look at number 2. A train moves with a uniform velocity of 36 km per hour. Look at this. Uniform velocity U, 36 km per hour. And you know that velocity can also have a subunit apart from meter per second. It can be measured also in kilometer per hour, which means you have to go and master how to convert from one unit to another unit. That is physics for you. Conversion of units is very, very important. Now we are given the velocity to be kilometer per hour, which we cannot use it like this. We can't use it like this. We have to convert this one back to meter per seconds. Let's see the question. A train moves with a uniform velocity of 36 km per hour for 10 seconds. See? 10 seconds. Calculate the distance traveled. Let me change this one to V. Velocity is distance over time. Distance will be equal to velocity times time. Velocity, distance over time. Distance will be equal to velocity times what? Times time. But you remember that velocity is 36 km per hour. So let's try and convert velocity to meter per second. 36 km per hour will now be equal to 36 times 1000 divided by 60 times 60. Hey, you may be looking, how do you manage to get all this? It's as simple as this. 36 km. 1 kilometer is equivalent to 1000 meters. Do you remember that? 1 kilometer is equivalent to 1000 meters. This is how we get 1000. Then per hour means 1 over hour. If 60 minutes is equal to 1 hour and 60 seconds is equal to 1 minute, then automatically to convert an hour to a second is going to be 60 times 60. So that's how it is being done. So let's start. How do we get the value of this? This cancel this. This cancel this. We are going to have 36 times 10 over 36. 36 times 10. That's what it remains. 6 times 6, 36. 36 times 36. What are we having left? 10 meter per second. Can you see that? As simple as that. Now we are getting the value of V. Then the work is simple now. Distance will now be equal to V, which is 10 meter per second. That is 10 meter per second times time, which is 10 seconds. 10 times 10, 100 meter. This is raised to power 1. This one, we cancel this. Then we have 100 meter. That is the distance. 100 meter. If you see something like this in your exam, it's a bonus mark for you. And all these questions are typically the questions that came out for some students like you during their own time. Question number 3 says, a car starts from rest. Take note of this. Whenever you hear the word, the motion of a body starts from rest. Starts from rest. It means initial velocity is equal to what? 0. Take care of that. Whenever you hear a body is being sent into motion and the body starts from rest and start moving with a uniform velocity or whatever, initial velocity U is equal to what? 0. So let's consider the question once again. A car starts from rest and accelerates uniformly with 5 meters per second squared. Uniform acceleration is 5 meters per second squared. And its final velocity is 40 meters per second. Calculate the time taken to accelerate. What are we doing here? You are still coming and say from A is equal to V minus U over T. We are looking for T. T will now be equal to V minus U over A. Our V is 40. Our U is what? 0. Our A is what? 5. 40 over 5. And what are we having there? 8 seconds. Simple. 8 seconds. Question number 4. a body starts from rest and moves with uniform acceleration of 6 meters per second squared, what distance does it cover in 30 seconds? Let's look at that. Before we can solve this, let's look at this formula that said S is equal to UT plus half AT squared. But we are told that U is equal to 0. So if U is to be equal to 0, everything here will be what? 0. And what we are having left is half AT squared. And we are looking for distance. We are looking for acceleration is there. But this is what I want to emphasize upon. Don't come and tell me S is equal to half half times A, 6 times, you now say, they say 30 seconds. You just put 3 there and go your way. You will miss it. This is what I'm trying. So the 30 seconds in this place is referring to T3 minus T2. That is, they are referring to when T is equal to 3 seconds and when time T is equal to 2 seconds. How do we do that? See, S is equal to half times 6 times, then other time now, we are going to have 3 squared minus 2 squared. This is the approach. T3 minus T2. If the examiner said 50 seconds, it's going